Um, Good morning, good afternoon, and good whatever. So, the topic that we'll be doing today is vertical projectile motion. Man, this is the very nicest topic in high school. Like, it's basically the nicest topic in physical sciences about vertical projectile motion. And most of the students complain about this topic. No, it's hard, it's complicated. Man, this is just a walk in the field. Like you just project a ball upwards and then you go to exam. Like this when you are studying, you don't have to read books. When you're at home, you just have to take that ball, that ball, and then throw it upwards, and then you see how it is traveling, and then boom, you go to exam and say, okay, that ball was traveling like this and this and this and this. Then sharp. Okay, I'm joking, guys. I'm joking. This is where you see your ancestors knocking or no, your future doesn't belong here. So vertical projectile motion simply means we have two things. You know, vertical means something up or down, right? Up or down. And then projectile, I want to explain this part first. Projectile and motion, you know, motion relates to movement of something, that is a motion. But what is exactly a projectile? I'll start from here. Projectile. A projectile is simply an object. That has been given an initial velocity and then moves under the influence of gravity. Then what do I mean? I mean, it's an object, any object. Let me make an example of a rubber. Okay, you see, this is an object. Once it has been given an initial velocity, what type of initial velocity? A vertical. In a vertical motion, like if I throw it upwards, after throwing it upwards, it is going to move under the influence of gravity, meaning that this rubber, once I throw it upwards or downwards, it is then a projectile. That is how simply physical science is. Okay, an object being given an initial v and moves under influence of gravity. All right, good. Then before we proceed any further, I want to give you the main definitions of this topic. This is the first definition, and then the other definition is free fall under the influence of gravity. Is it? I think there's only. Okay, let me just say only. Okay, there's also free fall. Free fall is a motion. Okay, we have free fall. This is simply a motion under which the only force that acts on an object is gravitational force only. If you miss our only, you are dead. Okay, let's say I have this rubber here, and then the moment that I let off the rubber, it was moving under the influence of gravitational force only, and it will ignore the effects of air resistance in high school level. Fine. Then motion under which the only acting force is gravity only. Guys, we'll follow up on the exam guideline. I'm just showing you how it works. Okay, so let's get to the real business. Let me make an example of this. And let me just say e.g. The only famous example you will ever find in projectile motion is an example of a building. Let's say this building is 10 meter high. This is the height of a building, and we have a ball here on the edge of the building, and that ball is thrown upwards. I didn't write a question because it will waste time. That ball is thrown upwards, and then they say the initial velocity v initial is equal to 2 meter per second. What else? Okay, good. So here we will say I will give you the main formulas that we operate using in this topic. So I'll just write formula. The first formula is Vf equals to Vi plus A delta T. And then we have Vf squared equals to Vi squared plus 2A delta Y. And then, okay, I'll explain the formulas. Then we have U delta Y equals to Vi delta T plus 1 over 2A delta T squared. The last one isn't much important, but I'll just write it in case. So, is it something like Vi plus Vf over 2? I never used this formula in high school. Something like this. This is our V final, V initial, but this one, I want to explain that this one, the acceleration part. The acceleration that we use in vertical projectile is the acceleration that is constant, is the constant value, which is 9.8 meter per second squared. Right? This is the one we use mainly in this topic. And then what delta T depends. Okay. So let's assume the first question says let me first explain these most important things. Number one, I'll just say maximum. I'm making a summary for you guys. Maximum height. Maximum height. Number two, I'll just say time interval. Let me just say time interval. I should have said time symmetry or something else. I want to explain these two important parts for now. I need this actually an introduction. And then what you must know is that this is the maximum height. This is the biggest height that the ball can reach. It won't go any further above this height. This is the maximum height. Meaning, or that is where the ball is turning. It's exactly the turning point for those who are doing mathematics. So at the maximum height, it means all Vf is equal to 0. Did I just say Vf here? It's V initial. Vf here is equal to 0 meter per second. But what is the acceleration? The acceleration is always 9.8 meter per second. In the exam, they'll ask you what is the acceleration at the maximum height. You will just see 9.8 meter per second downwards, and the acceleration always goes downwards. And acceleration has magnitude and direction. So okay. What time symmetry means, if the ball arrives here in 0.2 seconds, it means the same position here, it will be at 0.2 seconds. I don't know if you guys get what I'm trying to say. Meaning, if the ball was to reverse, it will arrive here at 0.2 seconds. That is exactly time symmetry. So let's dive into maybe simple calculations. And they say find another thing. Here V is also equal to 2 meter per second, but I get to velocity has magnitude and direction. Here it will be negative if here it was positive. This is where this on the same position. Our velocity are equal, but just different in direction. Right? So let's make simple calculation. Find the time taken by the ball to travel. To travel upwards and back to its initial position. I don't know if you get it. To travel to its initial position or something like that. Next time I'll just write down questions first. Okay, I will do it in two ways. So Vi plus A delta T here, and then I choose upwards as positive because you always choose direction. So my final velocity on the first step, I will take my final velocity as for the maximum height, which is 0, equal to initial velocity is 2 plus into negative 9.8, which is the acceleration, and then delta T. Then delta T will be, I'll take this one to the other side and divide by negative 9.8. 2 divided by this will be 0.2 seconds. But to travel from here to here, it's 0.2 seconds. Meaning, to travel from here to here, it will be another 0.2 seconds. Meaning, I just multiply by 2, and then multiplied by 2 is equal to, I think it's 0.4 seconds. That is my delta T right there. 0.41 seconds. Right. Okay. Another way in which I'll do this is I'll just say Vf is equal to Vi plus A delta T. I choose upwards as positive. What direction doesn't matter as long as if you become consistent with the single direction that you choose, then this will be negative 2 equals to 2 plus into negative 9.8 delta T here. And then delta T is equal to negative 4 divided by negative 9.8. That is 0.41 seconds. Guys, well, you choose however way you want as long as you're applying the principles of this topic. Like this is just a walk in the field. Just go in the field and walk, then you get total in the exam. Simple stuff. I'll stop from right here. This was just an introduction. Thank you for watching.